This video we will talk about how to use the STL library list. So we will use the list for our chaining implementation. So list is from the standard template library in C++. So the same thing, you can specify different data type to create the list object. So list, you can add your element at the front. So you can do the push from, or you can pop at the front, or you can push the node at the end or pop to the end. The good thing about the list is they kind of open up for both sides. You can push to the front or push to the end, or pop to the front or pop to the end. So that's a little different than the queue or stack. They can do the open ups to see how you want to add your node. And also sometimes you can insert your node, the element in a specific location. You can just find that node and erase that. Also, you can clear that. And also the most important thing, once you add or push back or push from one by one to the list, you also can use the iterator to go over each node to display that. So we see the example here. So this simple code, we just show you how can we create a list. So when we create a list, we can pass in a list by constant reference to display the information. So here we will show you how you will use the iterator to go over one by one. So simply we just create one list. The data type is string. We call slist. So that's why you can see here, we can push the node to the end. So we can do the pushback. So this example, we only do the pushback. Of course, if you want, you can push to the front. So then they will add to the front. So now then we can display the list. So then later on, we will add the information. So here, let me show you the first thing. How should we display a list? Like earlier we showed you, right? Whenever you want to display something, you want to pass in the object. But passing the object, we pass in by reference. So since your purpose is to display the content for the list, so that's why we pass in by constant reference. So here, since you pass in by the constant reference, right? So then, like earlier we said, in the list, you can use the iterator to go over the node from beginning to the end. But here, since you pass in by constant reference, so this iterator, they need to be a constant iterator as well. So the iterator, basically, the it, like a pointer, they start from beginning to the end. So that's why when you define a constant iterator, you need to tell them what kind of data type. Because the it, whenever you try to increment that, they just go to the next node. So on the other hand, you want to from the first node to the next node. It is a pointer. They need to know the offset. So how we go to the next. So that's why we told this constant iterator, I want to declare they are a string data type in the list collection. So since here we pass in a list, string list. So here your it, we can assign. So we assign from the list 1, this string list. So how should we start? So right, earlier actually we show you, when you do the iterator, you have the begin and the end. Begin actually is the begin reference location for the list. So that's why we assign the pointer to the beginning of the list. So each time we just increment by 1. They will according to your data type here to increment the size. So then our condition is when the it not equal to the end. So here, when you have the end for the list, they are the end address for the list. So on the other hand, if you have the array, so let me show you here. Okay, for example, we define a list here. So that's the string list. So we just say, for example, we have so many elements here. So when we ever to use the begin this member function, the begin means the beginning of the address. So that's why our it assigned from here. So then they will read one string each time. So then end actually means the end of the address for the list. So that's why you see when they increment by 1, when they reach to the end, we know we're done. So that's here our for loop like this. So your iterator start from the list begin. So then if not equal to the end, we just increment 1 by 1. So here, remember it is a pointer. The iterator just a pointer. So we need to display the element. We just need to dereference using the asterisk symbol. So this one is when you pass in the list by the constant reference. So on the other hand, your iterator, they need to be the constant iterator as well. So now back to our main function. So later when you see the output, we will first display each string. So now let's make our another iterator. I want to visit each element. So at the end, I want to append 0 to each string. So since you want to update the information, right? So we still can use the it, but now since you need to modify through the it, so that's why your it iterator cannot be const. So it just be an iterator. So still my it start from beginning, not equal to the end. So then I increment by 1. So when I access each element, I just append the 0 at the end. So now when I display my list again, so you will see each string, they will add the 0 at the end. So we have the iterator. So then the next one I want to show you erase. Anytime if you want to remove one node, so you can use the erase. So erase, you will passing the pointer. So again, since we need to find which, for example, we want to remove the 2, 0, this string. So still we're using the non-constant iterator. Start from beginning to the end. So if this it equal to the 2, 0, so then you erase that. So then we display our string list again. So we run the program, see what you get. Okay, so that's our output. So you will see that's originally we have hello world is nice to learn remotely. So then remember I use the iterator to add each string with a 0 at the end. So then we remove the 2. So after you erase that, so it's just remove that node. So then they follow by 1 by 1. So that's the list, how we use that. So in our training implementation, actually in our array, we will have each node actually is a list of the nodes. So then when we want to searching for our key, we need to find the index. So then when we find the list, so then we need to visit the list node 1 by 1. So you will see here, because each node, they contain key and the value. So that's why I don't know the data type. So actually, on the other hand, here is we have a template list. So template list, actually, we need to show you when you have the iterator to access that, right? So then they will be a little different. When you want to use the iterator it to access a list, but this list data type node, inside the node, they contain a template attribute. For example, do you know the K data type? Do you know the V data type? Actually, we don't know yet. So that's why in this kind of situation, in the template list example, when they have the iterator, we need to add the keyword type name. So this type name, we know actually now what we will write the list to access the list. They kind of like they have in a template function. So that's we need to be careful later when we want to use the list in our training implementation. We do need to use the it to access the node one by one. But because our nodes contain a template type name data, so that's why we need to add the type name. So we know here when we write the code, we don't have the size yet until the template type being replaced. So only this one definition is different. Other than that, your it for loop will be the same. So you see your it still start from, for example, here we say that if the list call x, so your it equal to the x begin. So then it not equal to the end. So then we'll increment our it. So then here, when you want to compare the key, you're just using the it. That's the pointer to refer to the key. So then when you reach the end, that's just mean we didn't find that. Okay, so that's what we want to show you here, the type name you want to use when you have your iterator. So that's the list.